Welcome back to the OpenAI Associate Developer course. In this lesson, we will develop the code to call the OpenAI Text-to-Speech API. Know that the term text-to-speech is often simply abbreviated or referred to as simply TTS. For our lesson on the text-to-speech or TTS functionality, we'll start by looking at the OpenAI API function we will need to call. This is OpenAI's TTS endpoint, and the function call is audio.speech.create. This call requires the following three properties to be included in the configuration object passed into this call. These required configuration properties are the model, input text, and the voice option. Now that we have a brief overview of the OpenAI TTS API function and some of the configuration properties used to call this function, let's go ahead and jump back into our code and see how to implement the TTS capabilities of the OpenAI API library. Let's start in our main.ts file. We'll start with the bare minimum setup and OpenAI initialization code that we've seen before. However, in this exercise, we will make an additional import. In our main.ts file, we'll import the fs module directly into our main file. We do this because all our audio will be written to a file, as it makes little sense to log the AI-generated audio to the console. With all our imports and basic boilerplate code in place, we'll now go ahead and add in the OpenAI TTS API call. In our main function, we'll add the call to the OpenAI audio.speech.create API function, passing in our OpenAI configuration object. Notice, the returned variable type from this call is a response object type. This is a standard Node type and is the object we'll use to retrieve the audio data. Next, we'll add a call which retrieves the audio buffer from our MP3 response object and converts it to a Node buffer type. Here, know that the AI-generated audio data is stored in the response object's array buffer, and we will pull the audio data directly from our MP3 responses array buffer and convert it to a Node buffer type. We need to do this since the fsWriteFile method expects a Node buffer when writing data to a file. And now that we have all our audio data in the proper objects and formats, we'll go ahead and call the fsWriteFile function and write our AI-generated audio to a file. Here, take note of our file's naming convention. From our OpenAI configuration object, we simply use the audio file name configuration property for the file name and the audio format property for the audio file's extension. And finally, just to verify the file name, we log the audio file name to the console. And that's it for the code we need in our main.ts file. With our main.ts file taken care of, we'll next add the required configuration properties to our defs.ts file before we can compile and run our code. Adding these configuration properties and variables into our defs file is what we'll do now. Back in our defs.ts file, you'll see that it's virtually empty. The only code currently in the file is the basic declaration of an empty OpenAI configuration object. We'll start adding the variables we'll use for the required configuration properties in our OpenAI configurations object. Here, as we have done in the past, we will declare some union variables to hold the values for the text-to-speech API configuration properties. We'll start by creating the variable used to identify the TTS model, which in our case is the TS-S-1 model. We'll then add our text-to-speech model variable to our configuration object. Next, we'll create a variable of type string to hold the text we want to convert to audio and name this variable utterance. Remember, the length of this string cannot exceed 4096 characters. And here too, we'll add our utterance variable to our configuration object. The variable we'll add is the union variable for our AI voice. In our case, we'll set our voice to OpenAI's Alloy voice. And again, we'll add our voice variable to our configuration object. Next, we'll directly set the speed configuration property to the default value of 1.0. Since this is just a simple numeric value, we'll set this directly in our configuration object to simplify our code. While most of the variables we've created will go into our configuration object, we'll create a string variable which isn't used in our configuration file. This variable is instead used directly in our main file. This is our audio file name. This is the string value we'll pass to the fsWriteFile method so that we can create the audio file with the desired file name. Accompanying the audio file name variable, we'll also create a variable to hold the audio format, which we'll also use to name the audio file's extension. However, unlike the audio file name variable, we will add this variable to our configuration object to ensure we get the audio back from the AI in the desired format. Note here that both the audio file name and audio format variables have the export keyword in front of them. This is necessary so that we can use these variables directly in our main.ts file when naming our audio file. Go ahead now and compile and run our code. You should now see the audio file name logged to the console and an audio file of that name in your project's parent directory. Try experimenting with different voices, speeds, models, and formats to see how they affect the generated audio. In summary, the configuration properties we use to set up the OpenAI TTS API call are the TTS model, the input text, the AI-generated voice, the voice's speed, and the audio response format. By understanding and correctly setting these properties, you can leverage the full potential of OpenAI's TTS API to create natural-sounding speech from text, enhancing the interactivity and accessibility of your applications. That's all for now. In our next lesson, we'll continue to explore the audio capabilities of the OpenAI API and look at the speech-to-text features. Stay tuned, and let's continue exploring the exciting capabilities of AI-powered speech technology.